Good morning. Today we're going to quickly go through finding exact equations, which specifically means that we're going to be finding the A value in a general form equation. So we're going to start with the warm-up that I did in class, simply because this kind of gets into the idea of what we already know. On this particular one, find the slope and equation of a line containing these 2 points. Way back when, in algebra, we had a slope formula. And we could plug in what we know and solve for the remaining parts to find the equation. So let's go ahead and do that method. I'm going to start with finding the slope, and I'm going to call the slope A for today because this is such a common theme for what we're doing. So negative 35 minus negative 80 divided by 20 minus negative 16. So this is negative 35 plus 80, which is going to give me, 45. And then 20 minus a negative 16 is going to give me 36. So now I have a fraction that I'm dealing with. And I am going to reduce that fraction. 45 and 36 are both divisible by 9. So I'm going to pause this for a minute and check my math. Yep, I'm good. Okay, so 45 divided by 9 is 5. 36 divided by 9 is 4, so 5 over 4. I can also put that in a decimal if I prefer because it's a terminating decimal of 1.25. So in our equation, y equals ax plus b, and this is, by the way, much easier with the point slope equation that we learned the other day, but I'm trying to drive home the point maybe of something that you've already done. We know a, this is our slope. We also know an xy, and I can use, oh, my Apple Pencil's dying. I can use either this set of points or this set of points. So I'm going to choose the 20, negative 35. So I'm going to put negative 35 in for y. I'm not going to put a because I know the slope is 1.25. I know my x is 20, and then I don't know the y-intercept. So 1.25 times 20 is 25, plus b equals negative 35. I'm going to subtract 25. And I get negative 60 for my y-intercept. So y equals, and I put my slope in, 1.25x minus 60. Goodness, 60 for my overall equation. This is not exactly what we're going to be doing today. This is pretty close, though, because what we're doing is taking what we know, plugging it in, and solving for what we don't. This could also work in our y equals a x minus h plus k. I would just plug in everything I know here and solve for what I don't. In this particular case, I can use, because this is linear, I could use any value for hk and then the other for xy and then solve for a. And that's what we're really going to be doing today in class. So I'm going to move on to the next one. My pencil will let me. All right. So what we did in class was I had everybody just kind of tackle this problem. Write the exact equation of a radical function with a locator point of negative 1712 that goes through the point 33, negative 8. So what I'm looking at here is a locator point. That is my hk value. And through the point, that's an x and a y. So my radical function has a general equation of y equals a times the square root of x minus h plus k. This is information you would get from your parent graph toolkit. I'm going to plug in everything I know. So I know that the y is negative 8. I know I don't know a yet. My x is 33. My h is negative 17, so x minus negative 17, so be careful with that. Double negative, and k is 12, so plus 12. And then I need to simplify and solve. And it's important to kind of think about stuff that we did in inverses to kind of solve for what we don't. Remember that A is being multiplied by this radical, so I can't separate those two entirely. I can get rid of the 12 though. So I'm going to get rid of the 12, so I have negative 20 equals A, and then I can simplify what's in the square root. 33 minus a negative 17 is 50. Now, some people are tempted here to square both sides. You don't want to do that because this is a negative 20, and if you square it, it becomes positive, and that will throw off finding your exact equation. So we're not solving in that method. Plus, we'd have a squared if we squared both sides, and then we'd be out of luck. Now, the square root of 50 is not a whole number, so I'm going to have to round it off. There's other ways I could go about it, but for today's purposes, I'm just going to round it off. So we have a times, now that I take the square root of 50, I get 7.07. This can also be written as 7.07a. Some people are more comfortable, most people are more comfortable with the variable behind it. And so what I'm going to do, if I'm multiplying these two things, is use the right function on my pen. Divide by 7.07. So negative 20 divided by 7.07 gives me an A of negative 2.8, and I'm going to round that to a 3. So my equation, y equals negative 2.83 times, whoops, not parentheses, times the square root of x plus 17, as I am taking that double negative here and making it a positive, and then plus k, so plus 12. So that is my equation. So I want you to note when you actually write the actual equation out, x and y stay x and y. Like any other formula, we need those to be variable. Okay, so let's solidify those steps, and we'll do the example along with it. So first, determine the equation that you're dealing with, and this is where your parent graph toolkit is going to come into play. So on our example, find the exact equation of a cubic function with a locator point 610 that passes through 1282. So we're dealing with a cubic function. So that is the wrong function again. Y equals a times x minus h to the third power plus k. So that goes with that step. The next thing I need to do is determine hk, that's my locator point, and xy. It's my 12 and 82. And then I'm going to substitute those in to my equation. So instead of y, I'm going to have 10. I still don't know a. Nope, I'm not going to have 10. My apologies. I was looking at the wrong thing. I'm going to have 82 because my locator point, that's my k that I want to put in there. So 10, oh my gosh, 82 in for y. I'm going to put 12 in for x, minus, and then h is 6. Close my parentheses, cubed, plus, and that's where I'm going to use the 10. So now let's solve for a. So I'm right here in my steps. Minus 10, so I have 72 equals a. I'm going to go ahead and simplify what's in the parentheses there. 12 minus 6 is 6 to the third power. 6 to the third power is 216. So I have 72 equals a times 216. Divide by 216. And I get 1/3. I get 0.33 repeating. I can also just reduce that fraction. Since that's not a terminating decimal, I'm going to go ahead and leave it as 1/3. And then my final step over here, write my equation with a, h, and k plugged in. So y equals 1/3 times x minus 6 to the third plus 10. And that is my exact equation. Those are the steps for finding it. The important thing here is that you know how to deal with the various equations, absolute value, radical, all those other ones. If you don't, I would refer back to Unit 1. That was around like 1.6, 1.7. Also in your inverse unit. So that would have been Unit 2. We did a lot of the same kind of work as well. So that's it for finding exact equations. Have a lovely day.